Today's lesson begins chapter 3. The major emphasis in this particular section, 3.1, is about functions. So our first goal is to define a function. A relation is any set of ordered pairs, any kind of pairs paired together any way, as long as you say this goes with this. A function is a relation in which each x is paired with one and only one y. I like to use the birthday example. Each person can have only one birthday. So the person's name would be X and the birthday would be Y. Now, more than one person can have the same birthday, but for each given person, the X, there can only be one birthday. We're going to look in the book. I'm on page 199, section 3.1, and we're going to see some examples of relations and functions and how they can be described. In example 1, they're giving you a relation, and they're showing you that each state is paired with their number of representatives. So it's a relation. A state goes with the number. Also note that no state can have more than one number of representatives. Therefore, in addition to being a relation, this one is also a function. I'm turning the page to 200, and here we see we're naming the person with their phone number. This is a relation because it's a pairing of information, but it's not a function because Colleen has two different phone numbers. Remember, one person cannot have two birthdays. One person cannot have, one X cannot go with more than one Y. So while this is a relation, it's not a function. In this example, we're pairing an animal with their life expectancy. It is a relation. Any kind of these pairings is going to be a relation. But in this particular one, each animal is paired with only one life expectancy, so that does make it a function. Now, both dog and kangaroo are paired with 11. That's okay, as long as for every X, there's only one Y. That makes it a function. One of the ways we describe a function is what we've been looking at, called a mapping. Another possibility for describing a function is called a roster. And that's where you actually list out the ordered pairs as they do in this example. In letter A, let's look at those. We see that the X values are 1, 2, 3, 4. Nothing is used twice, so it is a function. In section B, the X values are 1, 2, 3, 6. That makes it a function. No X is used twice. Notice that I'm not even concerned about the Y's, only the X values. In example C, my X values are -3, 2, 0, 1, -3. Whoops, not a function because -3 is used twice. It's paired with both 9 and 8. That causes it not to be a function. Now we're going to look at the actual exercises that are on page 211. In problem number 19, they're using my person and birthday example. Every person can only have one birthday, so that is a function. In this number 20, you see that Bob is paired with both Beth and Diane. That makes it not a function. For every X, there can only be one Y. Number 21 is not a function because 20 hours has two different pairings. Number 22, it is a function because every X is paired with only one Y. Now let's look at some of the ones that are described in a roster. I'm looking at problem number 23. The X values are 2, -3, 4, 2. It's not a function because of the 2 repeating. 2's paired with 6, 2's paired with 10. That makes it not a function. I'm looking now at number 24. The x values are -2, -1, 3, 4. None of those x values are repeated, so it is a function. So what I'd like for you to do now is to stop the video and write yes or no for problems 25 through 30. Is it a function or not? And then come back and check. For number 25, you should have written yes. For number 26, yes. Number 27, no. Number 28, no. Number 29, yes. And number 30, yes. Next, we're going to talk about finding values of a function or evaluating a function. I'm on the very bottom of page 203. And the problem asks us to find the values using f of x, and that does not mean multiplication. That's just the function symbol. F of x is 2x squared minus 3x, and we're asked to find all these different values. What I would recommend you do is to draw a box around the x and a box around the x. And what you're going to do, for example, in letter A, you're going to put 3 in both of those boxes. You're going to replace the x with 3 and evaluate it, or actually do the math. In letter B, f of x is just what it says, and then we're going to add to that f of 3. So whatever we got in answer A, we're going to add that to the expression 2x squared minus 3x. And then there's more to go. So I'm turning the page to look at how they worked out those examples. This is on page 204. You notice that for the 3x, they've substituted 3 in both places for the x. They've done the math and got 9. In section B, or excuse me, example B, they just took f of x, which is just the expression 2x squared minus 3x. They added to that the answer that we got from answer A, and that gave us the 2x squared minus 3x plus 9. In example C, 3 times f of x means take whatever f of x is and multiply it by 3. So we did that problem. In section D, we're going to substitute negative x in the place of x because the problem was find f of negative x. So we replace negative x in both spots. When you square a negative, it still becomes positive, so that's still 2x squared. But this negative times this negative made it become a positive 3x. In letter E, we are just multiplying the whole thing by -1 in effect. The negative in front just means multiply through the whole thing by negative, so that's how they got this answer. In example F, we're replacing x with 3x. Now when you square 3x, you have to square the 3 and square the x. So that becomes 9x squared. Then it has to be multiplied by 2. That's how we got 18x squared. Then we took the -3 multiplied by 3x. In example G, we're asked to substitute, we're finding f of x plus 3 right here. So we have to replace x with the quantity x plus 3. Now, to square x plus 3, you need to go off to the side and write down x plus 3 times x plus 3 and use the distributive property to multiply it all out. When you do, you'll come back and get x squared plus 6x plus 9. Then all of that has to be multiplied by the 2. Then on this part, you need to distribute the -3. So that gives us -3x minus 9. And then the very last step is to combine like terms. So we took the 12x and subtracted 3x and the 18 and subtracted 9. Now let's go to the homework problems from page 211, and we're going to look at problem number 43. Be sure you read the directions in the book so you'll see where I'm getting all these parts from. The function they gave of f of x is 3x squared plus 2x minus 4. So I notice I drew the boxes around the x's. That's what you're going to substitute into. So for part A, f of 0, I put a 0 in the boxes, and you can see there how I did the math and worked that out and got negative 4. For letter B, the problem was f of 1, and so I substituted a 1 in for the boxes and did the math and got 1 for the answer. In problem C, it was to find f of negative 1, so I have to put negative 1 in the boxes and do the math. For letter D, it was to put negative x in the boxes. So I did that, and I ended up with 3x squared minus 2x minus 4. For letter E, it's kind of different. It just means multiply by negative 1. So I took the function as it was given, multiplied it by negative 1, and you can see my answer there, negative 3x squared minus 2x plus 4. For section F, I was to replace x with x plus 1. So, in effect, I'm putting x plus 1 in the boxes. You see here I had to distribute x plus 1 times x plus 1. Then I had to multiply it all by 3. And then on the last step, I was collecting like terms. For part G, I needed to put 2x in the boxes. And remember, when we square 2x, you square both the 2 and the x. And you can see my answer there. Then for section H, now this one's a little bit harder. You have to put x plus h in the boxes. And so I'm going to come off to, well, you can see right there, I already did it. X plus h times x plus h. So I multiplied x times x. I multiplied x times h times x, and h times h. And these two are the same, so I could add those together to get 2. So every time I need to square x plus h squared, I'm going to get x squared plus 2xh plus h squared. Then because of this 3, all of that had to be multiplied by 3. This part had to be multiplied by 2, and the negative 4 just tags along from the original function. And then in this part, you can see where I distributed the 3, and there were no like terms, so that was my final answer for that problem. Now I would like for you to try problem number 45, and then stop the video, try it, and come back and check your answers. I'm going to help you get started. You see, here's the problem. And so notice that I drew boxes around the x's. And so whatever they give you, you're going to substitute into the boxes. So pause the video, try the parts for 45, and then come back and check your answer. All right, I'm going to run through the answers for 45, and then you can pause the video and look at the work if you need some extra help. For section A, I got 0. For B, I got 1/2. C was negative 1/2. D is negative x over x squared plus 1. E happens to be the same answer, negative x over x squared plus 1. F is x squared plus 1 over x squared plus 2x plus 2. G is 2x over 4x squared plus 1. And H is x plus h over x squared plus 2xh plus h squared plus 1. And none of those are like terms, so I can't combine anything. So that's my final answer for the parts of 45. So now let's go to 47. To help you get started, I've reminded you that you draw a box around the x. Remember, these values mean absolute value, which means if it's a number, you're just going to make it positive. So try the parts of 45 and see how you do, and then come back and check your answers. For A, I got 4. For B, 5. C, 5. D, the absolute value of x plus 4. You can't take that out of the absolute value. You can get rid of the negative sign, but you just have to leave that in there because we don't know whether x was positive or negative. And then on E, when you distribute the -1, it stays on the outside of the absolute value. That doesn't multiply on the inside, just on the outside. And then you multiply the 4 by -1. F, you can see my answer is absolute value of x plus 1 plus 4. And because this has an x in it, there's nothing else you can do to it. For G, I started out with the absolute value of 2x plus 4. And because this is a positive 2, you can slide that 2 out to the outside. But you have to leave the absolute value of x there. And then for H, I got absolute value of x plus h plus 4. And again, because those are both variables, there's nothing you can do but leave it like that. The last one we're going to do in this particular section is number 49. So I reminded you to draw the x's, draw boxes around the x's. And again, I'd like for you to try this one and then come back and check your answers. For part A, I got -1/5. For B, I got -3/2. For C, +1/8. For D, this is what I got originally. But if you multiply both numerator and denominator by -1, you get this. And the computer thinks this looks better than that. So if you've got lots of negatives in the denominator, you might want to multiply both numerator and denominator by -1. For E, I got this one. For F, I got 2x plus 3 over 3x minus 2. For G, I got 4x plus 1 over 6x minus 5. And you can see here for H, 2x plus 2h plus 1 over 3x plus 3h minus 5. Now, if you have any questions about those problems that we just looked at, I would encourage you to call me and ask me what I did on certain parts of it, or send me an email or a text and let me help you with that before you attempt the homework problems from the computer. There's one more section that we'll look at, but that's the end of this section. So I'm going to stop this video, then we'll start a new one in just a minute.